functions and its properties. I don't think now you find it difficult. Now after completing exercise 2.1, now we are doing exercise 2.2. So here is question number 1. Once you go through properties, the link is given in the description box. You find then that doing these sums is not a very difficult task. So question number 1 says, prove that, like written, 3 sine inverse x is equal to sine inverse 3x minus 4x cube. So suppose sine inverse x is equal to t. So x is equal to sine t, right? One thing, taking right hand side, put the value of x, sine t, sine inverse 3 sine t minus 4 sine cube t. You know very well 3 sine t minus 4 sine cube t is sine 3t, sine inverse sine 3t, and sine inverse sine 3t is 3t. T is sine inverse x. Here is the answer. This is left hand side. Same is second question. So I am taking third question. Question number 3 says, prove that tan inverse 2 upon 11 plus tan inverse 7 by 24 is equal to tan inverse 1 by 2. Hope you remember the formula. Tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy, where xy is less than 1. Let us check the condition first. If taking left hand side, right, tan inverse 2 upon 11 plus tan inverse 7 by 24. Check the condition, product of 2 by 11 and 7 by 24. So you see 7 by 11 into 7 by 2 by 11 into 7 by 24 is equal to 14 upon 4, 6 and 2, 264, which is less than 1. So we can proceed and apply the formula. Now the formula is tan inverse 2 by 11 plus tan inverse 7 by 24 is equal to tan inverse 2 upon 11 plus 7 by 24 divided by 1 minus 2 by 11 into 7 by 24. Right? Now, just little bit of calculation. 77 upon 264 or 11 into 24, whatever. 7 2s are 14 upon 264, cancel out. 55, 125 upon tan inverse 250. It comes out tan inverse half, which is right hand side. So here is your answer, and very important is to check the condition. Question number 4 in front of you. 2 tan inverse 1 by 2 plus tan inverse 1 by 7 is equal to tan inverse 31 upon 17. What is the difference in question number 3 and question number 4? Question number 3 says only tan inverse plus only tan inverse. Here you are given twice of tan inverse. So you remember formula, property number 6. 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square. Right? So just apply 2 tan inverse 1 by 2 is equal to tan inverse 2 into 1 by 2 upon 1 minus 2, 1 by 2 whole square. This is tan inverse, this is equal to 1 upon 1 minus 1 by 4, 3 by 4. It is equal to tan inverse 4 by 3. One more thing I want to remind you, to apply this condition, you must check the condition. Condition is that x lies between 1 and minus 1, and here is your x is 1 by 2, which lies between 1 and minus 1. Now, taking left hand side, right, 2 tan tan inverse 1 by 2 plus tan inverse 1 by 7 becomes, now it takes the shape like that, 4 by 3 plus tan inverse 1 by 7. Now it would be tan inverse, again to apply the same formula, tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy, provided x into y less than 1. 4 upon 3 plus 1 by 7 upon 1 minus 4 upon 3 multiplied by 1 by 7, provided 4 upon 3 multiplied by 1 by 7 less than 1. Yes, it is 4 upon 21. Now just write the answer. 7 4s are plus 3, 31 upon 7 3s are 21 minus 4 upon 21. 21 gets cancelled out. So tan inverse 31 upon 17. 21 minus 4. Here is your answer. Write the following function in simplest form. Your question number 5 is tan inverse square root 1 plus x square minus 1 upon x. You just want to simplify this function. I want to tell you something, that in case, this you have to always remember, in case there is a function in a form and you want to convert that function in other form, and you see under root 1 plus x square or square root x square minus 1 or 1 minus x square or square root of 1 minus x upon 1 plus x, then you must keep some tricks in your mind. What type? Suppose if there is involved a expression like this, square root of 1 minus x square, always put x is equal to sine theta or cos theta. Right? 1, 2. Suppose x square minus 1 is there. Suppose square root of 1 plus x square is there. Suppose 1 minus x upon 1 plus x, or any power, x square or x cube, whatever. Right? So let's move. X square minus 1 is there. Then x is equal to sec theta or cosec theta. For square root 1 plus x square, x is equal to tan theta or cot theta. X square root of 1 minus x square upon 1 plus x square, or I can say x to the power n is there. Anything is there. Any power is there. And with square root, always put x to the power n is equal to cos theta or cos 2 theta, whatever you like. So tan inverse square root 1 plus x square minus 1 upon x, if you look at it, this falls in third category. X is equal to tan theta or cot theta. Let us put x is equal to tan theta. What will happen? Right? Tan inverse square root of 1 plus tan square theta minus 1 upon tan theta. 1 plus tan square theta, sec square theta. Square root of sec square theta, only sec theta. Tan inverse sec theta minus 1 upon tan theta. On simplifying, sec theta can be written as 1 upon cos theta and tan theta can be written as sin theta upon cos theta. So upon simplifying, what we get? Tan inverse 1 minus cos theta upon sin theta. Right? Taking LCM, after taking LCM. So tan inverse 1 minus cos theta 2 sin square theta by 2. Remember half angle formula. Sin theta is 2 sin theta by 2 cos theta by 2. 2 cancel out. 1 sin theta by 2 cancel out. Sin theta by 2 upon cos theta by 2, tan theta by 2. So this is tan inverse tan theta by 2. And this is equal to theta by 2. And you know, if x is equal to tan theta, then theta is equal to tan inverse x. Look, you assumed your given x in terms of a new variable theta. So at the end of the question or answer, you must eliminate the variable which you have assumed. Your answer must be in the variable which was given to you. So you cannot leave your answer in terms of theta. You must write your answer in the given variable x. So theta is equal to tan inverse x. So here is your answer. Half of tan inverse x, right? So simplest form of tan inverse square root 1 plus x square minus 1 upon x is equal to tan inverse x upon 2. Now moving to the next question. Question number 6. Tan inverse 1 upon square root x square minus 1. Yes, I have given you a list and this falls in the category 2. X is equal to sec theta or cosec theta, whatever. Now let x is equal to sec theta. You may say, why ma'am, only you take the first one, you can take second one, you will find the same thing, right? X is equal to sec theta, tan inverse 1 upon square root of sec square theta minus 1, tan inverse 1 upon sec square theta minus 1, you know very well, tan square theta, this is tan theta, right? And 1 upon tan theta, cot theta. You know, tan inverse tan 90 minus theta. So it can be written as 90 minus theta. If x is equal to sec theta, then theta is equal to sec inverse x. So pi by 2 minus sec inverse x. This is cosec inverse x. You may leave your answer here or here. It makes no difference, right? Now moving to question number 7. Tan inverse square root of 1 minus cos x upon 1 plus cos x. You must have understood a point कि you need to remember all the formulas of trigonometry which we read in class 11. So 1 minus cos x is equal to 2 sin square x by 2. 1 plus cos x is equal to 2 cos square x by 2. Only sin x is equal to 2 sin x by 2 cos x by 2. I have written these formulas just for your reference. You again and again you are using these, right? Now tan inverse, you can see square root of 1 minus cos x can be written as 2 sin square x by 2 upon 2 cos square x by 2. 2 and 2 gets cancelled out. Sin square x by 2 upon cos square x by 2. This is tan square x by 2, square root and whole square cancel out. You are left with only tan x by 2. So x by 2. One more formula I want to give you a reminder. You know very well, tan a plus b. Do you remember? Tan a plus tan b upon 1 minus, just after this question we need that. If in place of a we put pi by 4 and in place of b we put a, then tan pi by 4 plus a becomes tan pi by 4 plus tan a upon 1 minus tan pi by 4 into tan a. That means 1 minus tan a upon 1 plus tan a. On simplifying we get cos A minus sin A upon cos A plus sin A. Make a correction here. This is plus and this is minus. Plus and minus. Right? So, moving to the next question. Question number 8. Question number 8. Tan inverse cos x minus sin x upon cos x plus sin x. We have already made our base. This is cos A plus sin A upon cos A minus sin A, 1 plus tan A upon 1 minus tan A, and this. So, take cos x common from numerator and denominator, 1 minus tan x upon 1 plus tan x. Right? Tan inverse, this can be written as tan pi by 4 minus x. Tan inverse 10 pi by 4 minus x will give you pi by 4 minus x. That's it. So simple. Now question number 9. Tan inverse x upon square root a square minus x square. Now you may say, ma'am, there is no a square. So we can make a change. If instead of 1, here we see a square, then we can put x is equal to a sin theta or a cos theta. In the same way, for square root of x square minus a square, x is equal to a sec theta or a cosec theta. 1 plus a square, if a square is there, a tan theta or a cot theta. A to the power n, then we can put a or a, whatever. So, you can put square root of a square minus x square, a square minus x square. You can put x is equal to a sin theta or x is equal to a cos theta. Let us put x is equal to a sin theta. So, it becomes, that means left hand side becomes tan inverse a sin theta upon square root of a square minus a square sin square theta, a square common, one minus sin square theta, cos square theta, square root of cos square theta, only cos theta. A gets cancelled out. Tan inverse tan theta. This is theta. But my question is not given in terms of theta. It is given in terms of x. What to do now? So, we have assumed that x is equal to a sin theta. Find theta in terms of x. Look, how come? X upon a is equal to sin theta. So, theta is equal to sin inverse x upon a. Right? So, our answer is sin inverse x upon a. Just have a look. Question number 11. This question is not a very tough question. If you know how to do exercise 2.1, then this is not an Herculean task to do this question. Look, you know how to find out the value of sin inverse 1 by 2? Sin inverse 1 by 2 is, suppose you don't remember how to find out, you know that what is half. In terms of sine, convert this half in terms of angle. This is sine 30 degree or pi by 6. Right? This is the principal value, pi by 6. Put the value here. Tan inverse 2 cos 2 pi by 6. Right? 2 3s are 6. So, tan inverse 2 cos pi by 3. Cos pi by 3. Again, 2 into 1 by 2. This is tan inverse 1. And you remember tan inverse 1 is pi by 4. So simple. Now, moving to the next question. Cot tan inverse A plus cot inverse A. You remember tan inverse x plus cot inverse x is equal to pi by 2. So, this can be written as cot pi by 2. And cot pi by 2 is 0. So simple. Question number 13. 10 half. Sin inverse 2x upon 1 plus x square, cos inverse 1 minus y square upon 1 plus y square. Very strange. This question is in terms of two variables, x and y. Then so what? We can do it. Put x is equal to tan theta and y is equal to tan phi. You remember there were three formulas. Let us revise once again. 2 tan inverse x is equal to sin inverse 2x upon 1 plus x square when mod x less than 1. Again 2 tan inverse x was cos inverse 1 minus x square upon 1 plus x square. So if you remember that formulas, so we want to derive this in terms of tan. When you put x is equal to tan theta, you can write it as tan theta upon 1 plus tan square theta, which is equal to sin 2 theta. So sin inverse sin 2 theta will give you only 2 theta. In the same way, 1 minus y square upon, you can apply direct formula also or you can derive it, tan square phi upon, but I think you must derive. This is equal to cos 2 phi. Hence, left hand side, or you can say this side, tan half of sin inverse sin 2 theta plus cos inverse cos 2 phi. Tan half of 2 theta plus 2 phi. 2 theta plus phi. Theta is tan inverse x and phi is tan inverse y. Tan inverse x plus tan inverse y. Can we apply the formula of tan inverse x plus tan inverse y? Yes, of course, because x into y is less than 1. It is already given to me. So it becomes tan inverse x plus y upon 1 minus xy. Wonderful. Tan inverse will be cancel out and x plus y upon 1 minus xy is your final answer. Now have a look. Hope you understood these problems. From 14th onwards we will do in next video, and please like, share and subscribe, and if you have any problem please write in the comment box. Till then, bye bye, and don't forget to press the bell icon.